Welcome to This Explainer. Today, we are embarking on a journey that is frankly going to bend your mind a little bit. We're going to completely dismantle how you think about location, about physical space, and honestly, about reality itself. We're going to start with the literal dirt right beneath our feet, zoom all the way out to a massive invisible mathematical grid wrapping our entire planet, and eventually, we're pushing all the way out to the surface of Mars. It's an exploration of the WorldID initiative and this incredible concept called the UIID, developed by LINKSPREED LLC. Get ready, because the way we map the physical world is about to change forever.
Okay, let's dive into this. On the surface, it sounds simple enough, right? But the engineering challenge here is just staggering. How do you perfectly index physical space? How do you give a completely unique, unbreakable digital fingerprint to a patch of grass in your backyard, a square of sidewalk in Tokyo, or even some remote glacier in Antarctica? Historically, our go-to solution has been to build massive, centralized databases. But here's the thing. Centralized databases are brittle. They can be hacked, they have single points of failure, and they require an immense, almost unbelievable amount of upkeep. The WorldID framework asks a totally different question. What if we didn't store locations at all? What if instead we calculated them?
Section 1. The ground floor. The problem with where.
To really understand the solution, we have to look closely at the problem. Imagine looking down at a single 1 square meter patch of dirt. How do you tell a machine exactly where that dirt is, permanently? There is a huge contrast between our old systems and this new world. Every day, we use standard GPS coordinates, technically known as WGS-84, which is the standard geographic coordinate system used by cartographers and satellites. It's great for getting you to the coffee shop, but for permanent, machine-level identification, they are deeply flawed because they are variable. They shift, they drift, and they rely on these centralized systems. Trying to anchor digital property to standard GPS is literally like trying to nail a painting to water. It doesn't work. The solution is LINKSPREED's UIID, or Universal Immutable Identifier. It normalizes all that shifting data, anchoring reality perfectly to a static, decentralized, mathematical 1 square meter grid.
Section 2. The UID system, calculated reality.
So, the crucial point here is something called zero storage truth. We are officially shifting away from standard stored location data and entering a brilliant decentralized framework. Think about it. We aren't building a massive, vulnerable server farm just to hold a digital map of the Earth. Instead, the UID is calculated instantly, right on the fly, by any device. Because it's derived directly from the physical coordinates of the Earth itself, the identifier is universal and immutable. It never changes. By doing this, we completely eliminate those massive server costs and the single points of failure that come with trying to index the whole planet in a centralized database. It's a real game changer.
Let's walk through exactly how this normalization process actually works. Step 1. The system segments the entire surface of the Earth into a hyper-precise 1 square meter grid. Step 2. It takes the physical coordinates of that specific square and passes them through an algorithm, converting them into a 256-bit cryptographic fingerprint. And finally, Step 3. We achieve a completely decentralized immutable identity. This guarantees that any device anywhere in the world running this algorithm will calculate the exact same UIUID for the exact same square meter. It becomes a shared, universal mathematical language.
Section 3. The math behind the magic. We've laid the ground floor, but to truly grasp the security and the sheer density of the LINKSPREED ecosystem, we need to zoom out from the dirt and dive into the abstract cryptography. And just a quick warning, the scale we are about to look at is quite literally incomprehensible to the human brain.
Get this. The total number of 256-bit combinations is approximately 1.15 times 10 to the 77th power. That is a massive number. Now compare that to the total square meters on Earth, which is about 5.1 times 10 to the 14th power, or roughly 510 trillion square meters. When you look at Earth's surface against all those available cryptographic addresses, the utilization ratio is an absurdly small 0.00, followed by 62 decimal zeros, 44%. Let that sink in. What you should take away from this staggering fact is that you could assign a unique UIID to every single atom on the surface of the Earth, and you would still have used less than 1/1000th of 1% of the available 256-bit addresses.
Which naturally leads us to a vital security question, one that really makes or breaks the entire concept of the WorldID Workspace. Could two places ever share the exact same UUID? Is it possible to have a hash collision,
where my square meter of land and your square meter of land somehow generate the identical 256-bit fingerprint.
Well, using the SHA-256 algorithm, the probability of a collision is approximately 1 in 10 to the 60th power. Just let that absolute mathematical impossibility hang in the silence for a second.
To put that into perspective, there is a brilliant analogy straight from the source material that illustrates the security perfectly. You are 10 to the 45th times more likely to be hit by a mass extinction level asteroid in the next second than to witness a UIID collision. It's slightly dark, sure, but highly memorable. It proves beyond a shadow of a doubt that the mathematical sovereignty of this system is absolutely bulletproof.
Section 4, the WorldID Workspace.
Okay, let's bring this massive math back down to reality. Now that we have these unbreakable universal anchor points, what do we actually do with them? Let's zip through some strategic applications, because this is why it matters to industries right now. First, autonomous infrastructure. Imagine delivery drones verifying their exact landing zones mathematically, without needing to constantly ping a vulnerable cloud server. Second, smart cities. City planners can build digital twins where each 1 square meter UIUID acts as a data container. Different organizations can overlay environmental metrics, land titles, or logistics routes seamlessly. And third, Web3 and real-world assets. The UIUID provides the perfect immutable bridge to link physical land directly to smart contracts. Because they all speak the exact same mathematical language, they can interoperate perfectly.
Let's move to Section 5 and see how this builds beyond planet Earth. Because you see, the LINKSPREED roadmap doesn't just stop at our atmosphere. We are zooming all the way out into the vastness of the solar system.
Because the UID framework relies entirely on math instead of centralized servers, it is inherently scalable to literally any celestial body that has a defined coordinate system. We already know Earth has about 510 trillion UID slots. But let's look at our planetary neighbors. Mars has a surface area giving it 144.3 trillion 1 square meter slots. The Moon has 37.9 trillion slots. The WorldID initiative is actually actively adapting the algorithm to create a Moon ID. This is absolutely crucial to support autonomous mining and habitat management as missions like Artemis increase our human presence in space.
The practical application here is just incredible. Think about the communication latency, the lag between Earth and Mars. It takes minutes for a signal to travel just one way. If a Martian rover needs to verify its location using an Earth-based server, it is completely paralyzed by that delay. But with a deterministic UID system, that Martian rover can identify its exact location locally, instantly, without waiting for terrestrial server confirmation. It creates a unified, cryptographic interplanetary workspace for managing assets across the entire solar system.
Which brings us to our final thought for today. We are witnessing a profound paradigm shift, moving away from brittle, human-managed stored truths toward an unbreakable, calculated reality. The WorldID Workspace is inviting us to organize the planet square meter by square meter. But the ultimate question is, are we ready to organize the stars? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time as we decode another fascinating piece of our world.